Good morning or afternoon if this is third period to my audio circuitry classes. I'm out today. I have COVID, so I expect to be back on Tuesday, and we will be having our certification test then. So this video will instruct you on what you need to get ready and prepare, as well as the lesson on parallel resistance. So a couple of things first. Let's talk about what you can and can't use on the certification test. So let me switch my screens here. Let's go here. So these worksheets, this is the new one for today, and these two from the past, you will not have access to on the test. Anything that you want notes-wise needs to be written in your notebook. You'll have this. You will also have access to a calculator that can just do those basic calculations, multiply, divide, square a number, whatever you need to. And if you are using that calculator, like, wait, how do I square something on here? You can always ask me. You're not going to be quizzed on your ability to use the calculator. It's just that I don't want you on your phones during the certification test. Okay, so that's what you'll have. You'll have this notebook. You'll have your calculator, and then it's online. So that's how it's going to work. We'll start like right away. It's not going to be like delayed by much. So if you have questions, get those out during the passing period beforehand, because I want to start within a few minutes of class. Okay, how you will be graded. So I've talked about this before, but I want to remind you that if you pass the certification test on this standard, you just get exceeding, just straight across the board. I don't need to check your work. I don't need to do anything else. You've done what's necessary to show that you've met that bar. If you do not pass, how I will grade you is based on your preparation. So here are the three worksheets that I'm looking to see that you have done like significant work in. You don't have to finish them. You don't have to complete them. It's that you've done the work to prepare yourself. That's more than just doing the teacher examples. That's more than just doing a handful of problems. That's significant work, okay? Oh, pause. Okay, so I wanted to show you also like what exceeding would be as far as preparation. So exceeding preparation would be actually completing these worksheets, doing each part, with a few exceptions. Like you don't have to do this chart. So this top problem on this page, you don't have to do. On this one, there's this page that had a ton of word problems. If you complete all the way through problem 10, except for problem 8, because we skipped that one, that'd be great. If you fully completed all those, that would work. I want to remind you that these problems, and I put up here on the table, I had us sketch out the schematics, so that would help us answer those ones. You're not required to write these from scratch. You are allowed to copy from my paper, which will be up here on the test. These are the diagrams that go with those problems. So put that there. Okay. So exceeding would be that completion. Another thing that I'll be looking for in your preparation is that you actually took notes. And this is not, oh, here we go. You took some notes on what we did in class. You wrote down different symbols and the things that you needed to know. You actually took those notes. You didn't just leave a completely blank notebook. And so that's what I'm looking for. Exceeding will be completing all those worksheets. Meeting is that you've done enough to prepare yourself and that you've taken notes. So that's how I'll grade it. I will enter in the exceeding grades on that day. And I will also, while you're testing, be grading your pedals, which I'll come back to. Okay, so now we're just going to get to today's assessment, which is this one. This blank paper is up on the desk here in front of my teacher desk, and it says parallel circuit problems. Okay, and so let me show you how this works. Okay, I'm going to do problem number 1, and I'm going to do problem, let's see here, problem number 5 down here. Okay. Okay, first of all, when it says REQ, let me zoom in here. When it says REQ, it means the equivalent resistance, meaning if I took this circuit and just made it one resistor, what resistor would be equivalent to these two resistors together? That's all it means. It essentially means the same thing as the RT did in the series one, which was resistance total. But yeah, so how do you find that? Okay, so in a parallel circuit, and you should write this in your notebook, if I have a signal being split into multiple pathways, and that can be 2 pathways, it can be 3 pathways, it can be 100. And then come back together. That's what parallel means. They have multiple paths they can go through. The circuit can flow through there, flow through here, flow through there. The equivalent resistance, the actual formula for it, is 1 over the equivalent resistance is equal to 1 over the first resistor plus 1 over the second resistor plus 1 over the third resistor, however many you have, plus dot, dot, dot. If you only have 2, then you just stop there, okay? That's how you calculate equivalent resistance. But what's key here is it doesn't actually give you equivalent resistance. It gives you 1 over equivalent resistance. So I'm going to grab a calculator, just 1 second. And this is a calculator you'll use on the exam, and I'll show you how to do this, okay? So here's how it goes. You take so turn it on, there we go, and go ahead and go 1 divided by, that's 1 over the first number, 12, plus 1 divided by the second number, 24, and you'll notice that it gives you a small decimal, because that's not the answer. That's not the answer, it's 1 over the answer. But this calculator has a trick up its sleeve where it can flip that over for you with 1 button press. So once I have this number, all I have to do is come find where it says x to the -1. Raising something to the -1 power is to divide by itself, 1 divided by itself. So it's to flip it over. If that's confusing to you, just press the button and hit enter, and it'll give you the answer. So there it is. So I did 1 over 12 plus 1 over 24. I got a number. That's not the answer. And then I do this -1 button. That will flip it over and give me the answer, 8 ohms. 8 ohms, equivalent resistance. So now when I look at current total, well, now I know the total resistance, equivalent resistance is 8, and the voltage is 24, and current is voltage divided by resistance. So I just go current is 24 volts divided by 8, and the total current is 3 amps. Okay. Now, what's the voltage? Well, these are parallels, meaning that this resistor is connected directly to the power source on both sides. So the voltage is always the same on everything in a parallel network. So that's 24 volts, that's 24 volts. That isn't new, we've talked about that. Okay, but then now if I want to calculate the current of this one, I1, current of this resistor, I have to take the voltage, which is still 24, and divide it by its resistance, 12. So this is 24 divided by 12, which is 2 amps. Okay, and then this one is 24 volts. It's always connected to 24 because it's parallel, so they're all the same, divided by 24 ohms, and that gives me 1 amp. And you know that you've done it right when your individual currents add up to your total current. 1 plus 2 is 3. So that's the process. The whole new thing is this process where you go 1 over the first one plus 1 over the next one, and if there's more, plus 1 over the next one, and so on. And at the end, press this magical -1 power button, flip it over. You can also do, let me just do this really quickly. You can go 1 divided by 12, it's 1 divided by 24. Like not all calculators have that -1 button. So if I just did 1 divided by, and I typed in that number, my answer there, I'd also get 8. So it's just 1 over that answer is what that button does. But that button does it quickly, and you'll have access to this on the test. Okay, let's do problem number 5. In problem number 5, they tell me the voltage and the total current. So voltage here, total current, because that's current is going and it's going to eventually be split, but that's the total. Okay, but they only tell me one of the 2 resistors. Okay, so how do we figure this out? First, well, this one is kind of a puzzle. Let's go with V1. Let's just do it in order. Oftentimes they put those problems in order for us on purpose. So the voltage across both of these is 12 volts because it touches both sides. So both voltages are 12 volts. And I can already tell where they're going with this. Okay, whoops. Okay. All right, and then it says current total, and I'm not sure why it tells me, oh, current total, duh, because they want us to just identify it. We don't have to calculate, it's right there. They just want you to identify it, to notice that it's there. You're not going to have to calculate it. But then let's do the current of number 1. Well, current again, to write it over here, current is voltage divided by resistance. And in this case, my voltage is 12. And my resistor here is 12. Let me get my head out of the way. Now 12 divided by 12 is 1. So this is 1 amp. Well, if this is 1 amp and the total is 3, then this must be 2 amps because 1 plus 2 is 3. Okay. All right, and now we've got resistor 2. Well, resistance, we have that formula. Resistance is voltage divided by current. And we know the voltage. The voltage is 12 volts. And now we know the current. The current is 2 amps. So 12 divided by 2 is 6 ohms. Which should make sense if resistor 2 has double the current. It should have half the resistance because it's resisting less, so more current. Now we can go ahead and figure out the total resistance. We could do it that way that I just showed you, but there's actually another way. Because of that equation right up here, voltage divided by current, we know that the voltage is 12 volts, and we know that the total current is 3. That would give us 4. 12 divided by 3 is 4. But if we chose to go this way, I could go 1 divided by 12 plus 1 divided by 6, because that's now 6 ohms, and then do that magic button, and it would also give me 4. So that's how you solve these problems. Again, doing it in order, answering the first problem first, second problem second. And sometimes it's asking you, as you saw here, for something you don't have to calculate, you just have to look. And it's already there. So don't overcomplicate that as you're going through. I'm going to leave an answer key. I'm going to finish this and leave this up there as a resource for you to check your work. But this is the last worksheet that we have. Now, if you finish like all the worksheets, you're fully prepared, you're ready to go, and you have more time. You now have the option to, and let me change this here so you guys can, you have the option to work on any pedal that's not finished. So you can go over there, even if your name's not on there, you can work on it. But there's a big catch. It should have someone's name on it, and if they're in the room, you have to get their permission from them to work on their pedal. And the second thing is you have to document everything that's your work so that it doesn't get confused with their work. So there you go. So if you feel fully prepared, you've done enough problems, you're like ready to go, and you know you're going to either pass the test or you've done enough to earn a meeting or even exceeding, and you're just like, what do I do with the rest of my time? That's what you can do. And tomorrow, I will grade the pedals. Okay? I'll see you.